Hello everyone, today we're talking chapter 11, areas of parallelograms and triangles. So let's take a look here. Our objectives will be to find perimeters and areas of parallelograms and find perimeters and area of triangles as well. So here we're looking at a parallelogram. First, of course, parallelograms, opposite sides are parallel. That's kind of the definition. Any side of a parallelogram can be a base, no matter what side we call the base. What is of note here is that the height must be perpendicular to a set of parallel bases. So the height always should be measured as the perpendicular segment to a base. All right. So that is important to know. And our key concept here, our first main idea, area of a parallelogram. The area A of a parallelogram is the product of the base B and its corresponding height H. So area equals base times height. Perimeter, again, that's the distance around the polygon, so the sum of the lengths of the sides of the polygon. Okay. So perimeter and area of parallelogram A, B, C, D here, find the perimeter and area. So as we look, the segment here that we're given, this 5-inch segment, that is perpendicular to these set of bases. So that'll be the height we use. So area equals base height. Area equals, again, we said we're going to use that 5-inch segment as our height, and of course the 10-inch segment is our base. So 5 times 10, here we have 50, and area is a squared unit, so inches squared. And for perimeter, of course, you just add all the side lengths up. So in a parallelogram, opposite sides are congruent, so 10 plus 10 plus 4 plus 4. We get that the perimeter is 28. And that's a linear unit, so inches, 28 inches there. Right, so that's how we find area and parallelogram, area of a parallelogram and perimeter of a parallelogram. So I'll give you guys an opportunity here to do 1B. Okay, so you can pause and do that. And all right, let's take a look here. So this one's maybe a little trickier. So this measure here that is perpendicular, it'd be perpendicular to these two sides. So these will be, our base will be 23, and let's call our height 24. So to find area, again we do 24. This is feet by 23 feet, and we get the area is 552. If you multiply those together, we get the area is 552 square feet. All right, and so for perimeter, we need side lengths. Of course, we've got this one is 23 feet as well. So those opposite sides are congruent. Unknown, though, would be this side, and so we need to use something to find that side. Of course, we can recognize it here. We've got this right triangle. Redraw that with 24-foot side and a 7-foot side. So if we find the hypotenuse, then we know what our other side of the parallelogram could be. So x squared is equal to, it's a pretty common problem for this type of thing, so you got to do a little bit more problem solving here. So 24 squared, 576 plus 49, 625. So the square root of 625, of course, is 25. So this side is 25 feet and this side is 25. So 25 times 2 plus 23 times 2, or just add them twice, either way. 50 plus 46, 96 feet for our perimeter there. All right, that's a good problem. You got to use a little bit of problem solving. Use the Pythagorean theorem, some prior knowledge on that type of problem. All right, so example 2, area of a parallelogram. Find the area of parallelogram EFGH. Here we've got to use some trig. Okay, what fun trig is. Why do we have to use some trig? All right, so if we're looking inside the shape, I'm going to highlight it here. I'll just use green again. This right triangle. What's tough about this right triangle, if we redraw it out here, we only have the hypotenuse length and an angle measure. So of course, to find the missing side, which over here we should call it H, we'd have to use some trig. So, well, how does H and 8.5, how do those relate? Well, we've got opposite of my 45 and the hypotenuse. So what trig ratio should we use? We should use sine. So sine of my 45-degree angle. A good problem solving one here where you got to use some prior knowledge. So sine of my 45-degree angle is opposite H over hypotenuse 8.5. So of course, if you guys are recalling, we gotta solve this for H. Got to multiply both sides by 8.5. So in your calculator, 8.5 times sine of 45. H, so you plug all of that in, and we're getting about 6. Should get 6. Let me double check. .01. So yeah, let's call it 6. 6 millimeters. So that's our height. So to find the area, we go base. Base is 15 millimeters times height 6. 15 times 6 is 90 millimeters squared. Be my area. Finding my perimeter, a little easier here. We go 8.5. Of course, the other side would go. So 2 times 8.5. 12. 15. Yeah, 30 here. What? 47 units. 50 millimeters. All right. So that's good. So on some of the problems, maybe on your homework, you're gonna have to use some trig. So remember, sine of an angle is opposite over hypotenuse. Cos of an angle adjacent over hypotenuse and tangent opposite over adjacent. So you might need that on some of the homework problems there. All right. That's definitely worth noting there. Let's continue. All right, I'll leave 2B for you guys. I think it's a good practice one. You're going to have to use some trig on 2B. Let's talk about areas of triangles next. So the base of a triangle can be any side, but the height must be an altitude drawn from a vertex and perpendicular to the base. So again, the height must be perpendicular to the base. Must be drawn from a vertex. And so then we get the area of a triangle, 1/2 base times height, or base times height over 2. These are the same. Doesn't matter how you write it. They're the same. All right, so find the perimeter and area of each triangle. So here we've got this altitude that's 30 inches. That is perpendicular to what side? That's perpendicular to by 19%. So area equals 1/2 19 ends up being my base. That's the side of the triangle. The height, the altitude is perpendicular here. So 19, 31 half of that. Of course, put that in here. And we'll get that the area is 285 inches squared. And for perimeter here, as we take a look, let me erase here just so we can clean this up. Look here, find perimeter, we got this 19-inch side, we've got a 41-inch side, we got to find this side. So again, let's use this time the Pythagorean theorem, x there being our hypotenuse, so x squared equals leg squared plus the other leg squared. Okay, so what, 27 squared plus 30 squared, you get 1629. Square root that. Let's do one decimal place here. You get 40.4 inches. And so our perimeter, 40.4 plus 41 plus 19. So that's about 100.4 inches. Alright, and so on this next one, a right triangle here, you just need to find the leg of the right triangle. That'll give you the height, and I'll leave that one for you guys. It's pretty standard. Yikes. Let's look at technology again. So another cool type of problem. Use area to find a missing measure. This one's interesting. The height of a triangle is 5 centimeters more than its base. So if we draw a triangle here, let's call the base x. So this bottom half side is x. So the height is 5 centimeters more than that. So it would be x plus 5. The area of the triangle is 52 centimeters squared. So find the base and the height. So then you just got to use area equals 1/2. In this case, the base is x. The height is x plus 5. Of course, we'll substitute 52 for a, and that'll give us an equation we're able to solve. Multiply both sides by 2 to clear my fraction. If 104 equals x times x plus 5. So that gives us 104 equals x squared plus 5x. And of course, it's a quadratic equation now that we'll need to solve, so we'll need the quadratic formula. Or using the quadratic formula, you've got to have this thing equal to 0. So do that. And you say a is 1, b is 5, c is negative 104. That's just from the standard form of a quadratic. Okay, plug all of those in. That's again the quadratic formula. I'll save a lot of this algebra and simplifying for you guys, but it's negative b plus or minus square root b squared minus 4ac all over 2 times a. When you plug in a, b, and c, you end up with x equals negative 5 plus or minus 21 over 2. Of course, if you do negative 5 minus 21 over 2, you get negative 26 over 2, which is negative 13. Negative 13 is not the answer because your base and height cannot be a negative number. These are linear measures. So then you do negative 5 plus 21 over 2. Negative 5 plus 21 is 16. 2, so you've got 8. So 8 is x. You go back up here. So x, your base is a, your height is a plus 5. Your height is, those are your answers. All right. Oh, units, I suppose. Sorry, centimeters. Centimeters. There you are. All right, so fun problem there. Your homework, 11.1, 783, 10 through 26 evens only. All right. Thanks for watching.